going to get introduced to the unit circle. So if you have your highlighter, you can highlight the following in your notes. What is a unit circle? It is a circle at 0, 0 with a radius of 1. And this is going to be the basis of what we're going to be doing in trigonometry in grade 12. Now, trigonometry, as you probably know, deals with triangles. So first of all, you might start to wonder, why are we bringing a circle into this? Well, if you pick any point on this circle, so that's what they've done right here. They picked a point. It has a random x coordinate and a random y coordinate, some point on the circle. You could always draw from that terminal arm back to the nearest x-axis and label your reference angle. And you would make a triangle, a right-angled triangle. And on that right-angled triangle, you could do the same right-angled triangle math that you did in grade 10, trigonometry. You could do a squared plus b squared equals c squared. You could do SOHCAHTOA. Now, if I did SOHCAHTOA, I could say that on this triangle, sine of theta, because sine is the opposite over the hypotenuse, well, my opposite side is y, my hypotenuse is 1. And cos of theta, being adjacent over hypotenuse, is x over 1. And at the bottom of page 470, there's a little bit of space. We're going to get introduced to 3 big ideas for this unit. And they all come from this little circle. Big idea number 1 is as follows. So I go back to this circle. If I draw that triangle, and sine of theta is y, and cos of theta is x, instead of writing my coordinates as x, y, I can now write my coordinates as the x coordinate is always cos of theta, and the y coordinate is always sine of theta. This is big idea number 1. To write it in words, big idea number 1. Points on the unit circle. Are cos of theta, comma, sine of theta. Super important math fact number 1, that you're going to want to have all the big ideas memorized so that you can use them. Because often in a question, if you're like, I don't know what to do. Well, have you thought about all of your big ideas? Because they can help you to solve this question. There's big idea number 1. Big idea number 2. Okay? Now, notice that it says in the box, the equation of the unit circle is x squared plus y squared equals 1. You've done equations of lines, you've done equations of parabolas. Never in your math have you done an equation of a circle before. In fact, the equation of a circle is really easy. All the equation of the circle is trigonometry. You know a squared plus b squared equals c squared? Notice the triangle that we made. It has an x, it has a y, it has a hypotenuse of 1. If you did a squared plus b squared equals c squared, you would get x squared plus y squared equals 1 squared. Well, and 1 squared is just 1. That is the actual equation of a circle. Anything that solves this will calculate every single point on that circle. And now, if x squared plus y squared equals 1, and your x coordinate is cos, and your y coordinate is sine, we could replace the x with cos. And in mathematics, when we square cos, we put the 2 in between the s and the theta. Otherwise, we have to put brackets, and we don't like writing extra brackets. So if the x is cos and the y is sine, same thing with sine, we write the squared in between the n and the theta, equals 1. This is big idea number 2. And it's on your formula sheet, which I haven't given you yet. But we're going to get a formula sheet in this unit. We had no formulas in the first unit. So big idea number 2. Now, for whatever reason on the formula sheet, they write sine before cos. So in the big idea, I'm going to write this is crazy. Because we can pick an angle, any angle, 27 degrees. If you had to do sine of 27 degrees, you would need your calculator. If you would type sine of 27 degrees into your calculator, there would be a lot of decimal places. But if you did sine of 27 degrees, got all those decimal places, then squared it, memorized all those decimal places in your head, then took cos of the same angle, 27 degrees, and squared it, and kept all those decimal places. You add them together, it will always equal 1. And it doesn't matter which angle we choose, 27 degrees, 38.7 degrees, 5,486.001 degrees. If you use the same angle in both places, square sine, square cosine, add them together, you will always get 1. This is big idea number 2. In fact, you just learned it right now, but by the end of this course, sine squared theta plus cos squared theta equals 1, you will think of something that you always have known, right? If someone told you right now, oh, on your formula sheet, nobody tells you a squared plus b squared equals c squared, does that bother anybody? Or do you feel like that's something that you know? That's like, in fact, if you see another student in grade 12, and you were talking to them, and you were discussing math class and how you were hypnotized or something like that, and you said, yeah, and we just learned a squared plus b squared equals c squared, and the person in grade 12 said to you, what? What are you talking about? You would look at them like, where have you been? Wouldn't you not be like, that would be weird if you talked to someone in grade 12 and they never heard of a squared plus b squared equals c squared? That would be very, very weird. I ordered new batteries. We'll see if they come in. We'll also see if the switch of batteries actually works, or if it just goes dead at this point. So this will be big idea number 2. Will be something by the end of this year that you will feel that you've always known. And you don't need a formula sheet for it. In fact, if you saw other people, you'd be like, you've never heard of that before? And then big idea number 3. We did sine theta, we did cos theta. Which one didn't we do? We didn't do tan of theta. Well, from grade 10 trigonometry, you know tan of theta is the opposite side over the adjacent. So there's my angle. The opposite side is y. The adjacent side is x. But since y is sine of theta and x is cos of theta, we have big idea number 3. That tan of theta is always equal to sine of theta divided by cos of theta. How powerful are these big ideas? Well, these big ideas explain the CAST rule. You learned the CAST rule in grade 11? Do you remember the CAST rule says where things are positive? So I'm going to here's a quick review of your CAST rule. The CAST rule says that all are positive. That's what the A stands for. When you get to a letter, the letter says only sign is positive in quadrant 2. That's what your CAST rule told you, where things are positive and where things are negative. And your unit circle explains that. Because if I pick a random coordinate in quadrant 2, can you see that your x coordinate is negative and your y coordinate is positive? So if my x is cos and y is sine, can you see that sine would be positive, cos is negative, and if tangent is y divided by x, or sine divided by cos, it's also going to be negative. If I pick a point in quadrant 3, both the x-coordinate and the y-coordinate would be negative. So sine will be negative, cos will be negative, but tangent will be positive. And if I pick a point in quadrant 4, the x-coordinate is positive, the y-coordinate would be negative. And so the unit circle explains our CAST rule. Why is it that some things are positive in some quadrants and negative in other quadrants? In grade 11, we learned our CAST rule just by looking for patterns. We would pick an angle in quadrant 2 and say, what's sine, what's cosine, what's tangent, and notice, oh, only sine was positive, the other ones were negative. And we created the rule that way. Now, we can use the unit circle to explain why the CAST rule works. And on page 470, we also get introduced to 3 new trig functions. Up till now, you've only learned about sine, cosine, and tangent. There are 3 other ones. They are called the reciprocal trig functions. There is secant, cosecant, and cotangent. And what I'd like you to do is decide secant, write 1 over cos theta. Beside cosecant, write 1 over sine theta, and with cotangent, write 1 over tangent, but because tangent is sine theta over cos theta, we can use that big idea to also say that cotangent is cos theta over sine theta. And these are our reciprocal trig functions.